Hello students, in this video we are going to see about variance and standard deviation and some exercise problems. So limitations of mean deviation. In a series where the degree of variability is very high, the median is not a representative central tendency. Thus, the mean deviation about median calculated for such series cannot be fully relied. The sum of the deviations from the mean is more than the sum of the deviations from median. Therefore, the mean deviation about the mean is not very high scientific. Thus, in many cases, mean deviation may give unsatisfactory results. Also, mean deviation is calculated on the basis of absolute values of the deviation and therefore cannot be subjected to further algebraic treatment. So, this implies that we must have some other measures of dispersion. Standard deviation is such a measure of dispersion. So, variance and standard deviation. Recall that while calculating mean deviation about mean or median, the absolute values of the deviations were taken, that is modulus of xi minus x bar. The absolute values were taken to give meaning to the mean deviation, otherwise it may cancel among themselves. Another way to overcome this difficulty, which arose due to the sign of deviations, is to take square of all the deviations. Let's see what is variance. So we can take the formula 1 by n sigma of xi minus x bar whole square. It is a quantity which leads to a proper measure of dispersion. This number, that is mean of the square of the deviation from mean, which is called the variance, and it is denoted by sigma square. So that symbol is said to be a sigma. So sigma square, which is represented as a variance. So variance of n observations x1, x2, x3 till xn, which is given by sigma square equal to 1 by n, sigma I equal to 1 to n, xi minus x bar whole square. Then standard deviation. It is the calculation of variance. We find that the unit of individual observation xi and the unit of the mean x are different from that of the variance. Since variance involves the sum of the squares of xi minus x bar whole square, for this reason, the proper measure of dispersion above the mean of a set of observations is expressed as positive square root of the variance and is called the standard deviation. Therefore, standard deviation is usually denoted by sigma. So, variance is denoted by sigma square. Here, standard deviation is sigma, which is given by square root of 1 by n, sigma I equal to 1 to n, xi minus x bar whole square. So, sigma square, which is variance, 1 by n of summation I equal to 1 to n, xi minus x bar whole square. Standard deviation is sigma, which is equal to square root of 1 by n, summation I equal to 1 to n, xi minus x bar whole square. Let's see some exercise problem finding mean and variance. So find the mean and variance for each of the data from the questions 1 to 5. So this is question number 1, 6, 7, 10, 12, 13, 14, 8 and 12. Here xi equal to 6, 7, 10, 12, 13, 4, 8 and 12. So sigma xi, summation of xi, which is the sum of the numbers. So data given n equal to 8. So we have sigma xi, which is 72. So mean is 72 by 8. So mean x bar, which is equal to 72 by 8, which is equal to 9. Here 8 is sum of the observations and n equal to 8, which is the number of observations. So mean x bar equal to 72 by 8, which is equal to 9. Now sigma xi square, which is square of these numbers. So 6 square plus 7 square plus 10 square plus 12 square plus 13 square till 12 square. So adding these we get 722. Now we are going to find variance. Variance sigma square equal to n into sigma of xi square minus sigma xi whole square. Here xi square is square of the numbers. Sum of the square of the numbers. Here xi is sum of the numbers. So 72, which is whole square. Here this is sum of the square of the numbers, which is 722. So which is equal to 8 into 722 minus 72 whole square by n square. Otherwise it is sigma xi square minus sigma xi whole square by n. So we can cancel this 1n from numerator and denominator. So it is 722 minus 72 whole square by 8, which is we get 592 by 64, which is equal to 9.25. So variance is 9.25. If you want to find standard deviation, then it is square root of variance. So sigma equal to square root of 9.25. So we get some 3 point something. Third one, find the mean and variance of first 10 multiples of 3. Here xi is 10 multiples of 3, which is 3, 6, 9, 12, 15, 18 till 30. So n is 10. Number of observations is 10. So summation xi, that is sum of all the 10 numbers, 3 plus 6 plus 9 till 30, we get 165. So to find mean x bar, which is equal to sigma xi by n, which is 165 by 10, which is equal to 16.5. Now we are going to find variance using this formula, sigma square equal to 1 by n, summation I equal to 1 to n, xi minus x bar whole square. Otherwise you can do the previous formula which I used in question number 1. So here I am using this formula. So this is xi. Xi is 3, 6, 9, 12, 15 till 30. The sum of these numbers are 165. Here xi minus x bar, which is, we have x bar is 16.5. Then xi minus x bar, 3 minus 16.5, which is minus 13.5, and 6 minus 16.5 is minus 10.5, and 9 minus 16.5 is minus 7.5, till we have 30 minus 16.5, which is 13.5. Here it is modulus of xi minus x bar whole square. So minus 13.5 will become plus. So 13.5 whole square, which is 182.5. Here minus 10.5, so it's become positive. 10.5 whole square, which is 110.25. And again let's see this value, 24 minus 16.5, which is 7.5. The whole square is 56.25. Then 30 minus 16.5, which is 13.5. Whole square is 182.5. So sigma modulus of xi minus x bar whole square is 742.5. When we add all these values, we get 742.5. The formula used to find the variance, which is sigma square equal to 1 by n, summation I equal to 1 to n, modulus of xi minus x bar whole square, which is 742.5 by n is 10. So when we divide this, we get 74.2. Fifth question, find the mean and variance of the following data. So this is used to find the variance of discrete frequency distribution. Here xi and fi are given. The frequencies are given. So I have written this. Then sum of the frequencies like 3 plus 2 plus 3 till 3. Sum of the frequencies are 22. Then finding the mean x bar equal to 1 by n sigma fi xi. Here n is sigma fi, the sum of the frequencies, which is 22. Then fi xi, we have to find the product of these two. So 92 into 3, 93 into 2, we get 186. Then 109 into 3, we get 327. Sum of these, adding these numbers, we get 2200. So 276 plus 186 etc. till 327. When we add this, we get 2200. So the formula is to find x bar is sigma fi xi by capital N, which is 2200 by 22, which is equal to 100. So mean x bar equal to 100. The next column is xi minus 100. So 92 minus 100, which is minus 8. 93 minus 100, which is minus 7. Then 109 minus 100, we get 9. So xi minus 100 whole square, that is minus 8 whole square is 64. Then minus 7 whole square is 49. Then minus 3 whole square is 9. Then we get 9 square is 81. Then fi into xi minus 100 whole square. Here fi we have 3. So 3 into 64, which is 192. Then 2 into 49, we get 98. 3 into 9, we get 27. Then 2 into 4, which is 8. 6 into 4, 24. 3 into 4, 3 into 16, we get 48. Then 3 into 81, we get 243. So sum of these are 640. When we add all these values, we get 640. The formula is to find the variance sigma square equal to 1 by n summation I equal to 1 to n fi into xi minus x bar whole square. Here it is 640. So 640 by 22 we get 29.09. So variance sigma square equal to 29.09. If we ask to find standard deviation, then it is sigma equal to square root of some 29.09. We get the standard deviation. Standard deviation of a discrete frequency distribution. So this is for group data. Let the given discrete frequency distribution be x, x1, x2, x3 till xn, and frequency we have f1, f2, f3 till fn. So the formula is to find standard deviation is sigma equal to square root of 1 by n summation I equal to 1 to n xi minus x bar whole square, where capital N equal to summation I equal to 1 to n fi. Then standard deviation of a continuous frequency distribution. The given continuous frequency distribution can be represented as a discrete frequency distribution by replacing each class by its midpoint. Then the standard deviation is calculated by the technique adopted in the case of a discrete frequency distribution. If there is a frequency distribution of n classes, each class defined by its midpoint xi with frequency fi, then standard deviation will be obtained by the formula sigma equal to square root of 1 by n summation I equal to 1 to n xi minus x bar whole square, where n equal to sigma I equal to 1 to n fi. 8th question, find the mean and variance. Here classes are given 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50, and the frequencies are given as 5, 8, 15, 16 and 6. Then we have to find the mid value of xi. Here xi is given as 0 to 10 to then 50. So mid value of xi is average of these two numbers. So 10 by 2, which is 5. Then mid value of 10 and 20 is 15. Otherwise you can find the average of these two numbers. So 20 to 30 mid value is 25, then 35, and 45 is the mid value of 40 and 50. Then fi, the sum of the frequencies are 50. When we add all these numbers, 5 plus 8 plus 15 plus 16 plus 6, we get 50. Then ui is xi minus a by h. Assumed mean is a. So mid value of all these xi's. So mid value is 25. Then assumed mean a equal to 25. And 10 is the class size h. So 0 to 10 we have class size h equal to 10. So ui equal to xi minus a by h. Here xi is 5. So 5 minus 25 by 10, which is minus 2. Then 15 minus 25, which is minus 10. Minus 10 by 10 is minus 1. 25 minus 25, 0. 35 minus 25 by 10, which is 1. Then 45 minus 25 by 10, which is 2. Then fi ui is the product of fi into ui. So 5 into minus 2 minus 10. 8 into minus 1 is minus 8. 15 into 0 is 0. 16 into 1 is 16. And 6 into 2 is 12. Then this is enough to find the mean x bar, which is a plus summation fi ui by n into h. Assumed mean a is 25 plus fi ui is 10. So 10 by n is the sum of the frequencies. So 10 by 50 into h is class size. So on simplifying this we get 27. So x bar is 27. Then finding the variance. Here fi into ui square. So first we have to find the square of this ui. Minus 2 whole square is 4. So 5 into 4 we get 20. Then minus 1 whole square is 1. 8 into 1 is 8. So 15 into 0, 0. Then 16 into 1 is 16. Here 2 square is 4. 4 into 6 is 24. So adding these numbers we get 68. Here variance sigma square equal to h square into sigma fi ui square by n minus sigma fi ui by n whole square, which is h is 10, then fi ui square is 68. So 10 square into 68 by 50 minus 10 by 50 whole square, which is 100 into 34 minus 1 by 25, which is equal to 100 into 33 by 25, which is equal to 4 into 33 equal to 132. So sigma square is 132. 10th question. The diameter of the circles, which is given in millimeter, drawn in a design are given below. So we have to calculate the standard deviation and mean. So the hint given as first, we have to make the data as continuous frequency distribution. Here data is given as 33 to 36, 37 to 40. So we have to make this as continuous. So lower limit we have to subtract minus 0.5 and upper limit we have to add 0.5 so that we can get a continuous frequency distribution. Here it is 32.5, 36.5, 36.5 and 40.5, which is continuous. So mid value of these are 34.5, 38.5, then 40.5 to 44.5, mid value is 42.5, then 46.5 and 50.5. The frequencies are given as 15, 17, 21, 22, 25. The sum of the frequencies are 100. Then assumed mean A is the mid value 42.5. Then using the formula Ui equal to Xi minus A by H. Here class size is 4, H is 4. Then substituting the value, here Xi is 34.5 minus 42.5 by 4 is minus 2. Then we get minus 1, 0, 1 and 2. Then Fi into Ui, that is multiplying Fi into Ui. 15 into minus 2, which is minus 30. 17 into minus 1, which is minus 17. 21 into 0 is 0. 22 into 1 is 22. 25 into 2 is 50. Then we are going to find Fi Ui square. So Ui square is minus 2 whole square, which is 4. So 4 into 15, which is 60. Then 1 into 17, 17. 0 into 21 is 0. Then 22 into 1 is 22. Then 2 square is 4. So 4 into 25 is 100. So sum of all these are, we get 199. Mean X bar is A plus sigma FIUI by N into H. A is 42.5 plus sigma FIUI is, we have 25, then N is 100. So 25 by 100 into class size H is 4. So 42.5 plus 1 we get 43.5. X bar is 43.5. Then standard deviation is, the formula is H by N square root of N into sigma FIUI square minus sigma FIUI whole square. So otherwise it is sigma FIUI square by N minus sigma FIUI by N whole square into H. So substituting the values we get 5.55. So sigma standard deviation, which is equal to 5.55. Thank you students.